Mathematics and Physics 10th part. Today's topic is also about differentiation only. But what is the geometrical meaning of differentiation? First we will learn. The geometrical meaning of differentiation is very much useful in analysis of graphs in physics. First of all, to understand the geometrical meaning of derivative or differentiation, we should have knowledge of secant and tangent to a curve. First, we will learn about secant, students. Secant, a straight line. Secant is a straight line intersecting a curve at two different points, at any two different points. Suppose if you take a graph here, so let me take this as a x-axis, this is y-axis and this is x-axis, and let me take the curve here. Where the curve represented is like this. This is a curve. Here, to this curve, I am taking a curve, to this curve, if we draw the tangent, first of all, secant, if we draw the secant, secant is a straight line intersecting the curve at two different points, any two different points. So let me take this point as P, this point as Q. So this yellow color line is called secant. So secant always intersect the curve at two different points. Now what is this tangent? Tangent is also a straight line touching the curve only at one point. For this, let me take the same diagram, the previous diagram. So this is a y-axis, this is x-axis. So in this we are going to write this as x, this as y, and the curve that we are denoting here is like this. And this yellow color line is secant. Now what is this tangent? Tangent is also a straight line, but it is touching the curve only at one point only at one point. Here, in this case, if you take this one, and this one, we know this is x, this is x, this is x plus delta x. Similarly, this is y and this is y plus delta y. So these are the 2 points P and Q. In this, students, let me take the same diagram. This is similar diagram. Now, if you reduce this delta x here, from here to here, this distance we call it as a delta x. From here to here, this is a delta x, this distance. The horizontal distance between P and Q is delta x. The vertical distance between P and Q is delta y. Now, if you reduce the delta x to a very small value, so first let me take the same secant first. This is our secant. This is P, this is Q, and if I reduce this one, when delta x is reduced, this is x, this is x plus delta x. When delta x is reduced, then we can say when delta x is reduced here, so I am reducing this delta x, I am reducing this, that is reduced to a very small value, then the same diagram I am going to draw here. This diagram can be redrawn like this. This is x-axis, y-axis, x-axis, and the curve that we are taking here is like this, and delta x is very small. Then this curve can be drawn like this. This is intersecting this only at one point. Let us say this is P. I just reduced the x. So now, if you take this one, this will give theta, and tan theta is given by, this is the delta y, this is the delta x, this is delta y by delta x. If you limit of delta x tends to 0, when delta x is reduced, we can write delta y by delta x as small change in y by small change in x. This is nothing but slope. So this is the geometry meaning of differentiation. The slope of a curve, at a given point is, the slope of curve at a given point is equal to differentiation of y with respect to x, that is dy by dx is equal to tan theta. So slope of the any curve at a given point is equal to the differentiation of y with respect to x. Of differentiation, students, some of these rules are very important while solving the problems from differentiation. The first one, derivative of a constant or differentiation of a constant. If you differentiate any constant with respect to x, with respect to y, with respect to time, this is always 0. Derivative of a constant, where c is a constant here, c is a constant. For example, d by dt of 3, differentiation of 3 value with respect to time is 0, because the value of 3 never changes. Today value of 3 is 3 only, tomorrow it will be 3 only, after 10 years 3, after 10 lakh years also the value of 3 remains as 3 only. So it is not changing with the time. That's why differentiation of 3 value with respect to time is 0. Similarly, d by dt of minus 2 by 7. This is also constant, minus 2 by 7. So this is also 0. And d by dt of suppose root 3 is also 0. So differentiation of or derivation of any constant value is always gives 0. So this is most important point that you have to remember. So if c is a constant, derivative of constant with respect to any variable is 0. Any variable, not only time, it may be d by dx of x or d by d of y, what may be. So derivative of a constant with respect to any variable is 0. Now, second one, most important rule and most important formula also for differentiation called power rule. So, what is this power rule? D by dx of x power n is equal n into x power n minus 1. This is the most important formula while solving problems of differentiation and basic formula also. Here, if you observe this one, the power of this x decreases by 1 first, and the result is multiplied with n. For example, we will see one example. D by dx of x square is, first power reduces by 1. Power reduced by 1 and multiplied with that power only, that power multiplied with the same power. So here x square. So first step is reduce the power by 1. So this will become x power 2 minus 1 and multiply this with same power, same power. So here power is 2, so 2. So answer is x power 2 minus 1 is x power 1 into 2. This will become 2x. Similarly, if you take d by dx of x power minus 1, now here also first step is reduce the power by 1. This will become x power minus 1 and multiply with the same power minus. This will become x power minus 2 into minus 1 into minus 1. Similarly, one more example, d by dx of x power minus 7 will become power reduced by 1 minus 7 minus 1 x power minus 8 multiplied with the same power. So this is minus x power minus 8. So this power rule is whenever this x is given, x power is given, this is x power n. If you take some more values here, I will write x power 1, x power 2, x power 3, x power 4. These are the functions and the corresponding derivative is power reduces by 1. So this will become x power 1 minus 1 multiply this with the same power. Similarly, this will become x power 2 minus 1 multiply with the same power 2. This will become x power 3 minus 1 into 3. This will become x power 4 minus 1 into 4. This is 4x cube. This is 3x square. This is 2x. This is x power 0 is 1. So these are the examples for power rule, and power rule is most important. That's why we are writing this in a box. D by dx of x power n is equal to n into x power n minus 1. D by dx of d by dx of x power n is equal n into x power n minus 1. Very, very important power rule. Third one, the constant multiple rule. Suppose a given function is a product of a constant and a variable. So, for example, 3x is given. So, derivative of 3x is how much? So, how to solve these problems? First, let me write the general formula d by dx of a constant and a variable. So, when this type of problem is given, first bring the constant outside. If only constant is given, derivative of constant is 0. But constant with the variable is given, bring the constant outside. So, this is constant will come outside. Then this will become d by dx of x. Now, here d by dx of 3x, first bring the 3 outside. D by dx of 3, 0 students. D by dx of 3 is 0. D by dx of 3x is not 0. First bring the 3 outside. So I brought 3 outside. Now the remaining terms d by dx of x over 1. This will become 3 into this power reduced by 1. X power 1 minus 1 multiply with 1. This will become x power 0. X power 0 is 1. Answer is 3. Similarly, one more example. D by dx of 4x cube. So this is also a constant and a variable. So first bring the constant outside. D by dx of x cube. Derivative of x cube is students 3x square. This will become 3x square into 4. 4 3s are 12x square is the answer for this constant multiple rule. And the fourth one is sum rule. Sum rule is just d by dx of u plus v. So when a function is having two variables u plus v, and if you are differentiating this with respect to x, you just write this as d by dx of u plus d by dx of v. This is called a sum rule in differentiation. The product rule. Students, if you take two variables which are differentiable with respect to x, so then d by dx of uv, u is differentiable with respect to x, v is also differentiable with respect to x, and differentiable with respect to x. Now this formula can be written as, first to bring the first variable outside, u into dv by dx, that is derivative of the second term, plus v into du by dx. This can also be written as uv prime. This is u into v prime plus v into u prime, both are same. For example, d by dx of x cube, or we can write x square first. X square can be written as d by dx of x into x. This is u and this is differentiable with x. This is also differentiable with x. So this can be solved as, first x you bring it outside, d by dx of x. The second one outside, d by dx of x. This is d by dx of x is 1, d by dx of x is 1. So x into 1 is x plus x, which is equal to 2x. Directly we can write without using this product rule. Without using this product rule, we know derivative of x square is by using the first formula or second rule, that is power rule. D by dx of x square is power reduces by 1, multiply with the same power. This will become x power 1 into 2, which is equal to 2x. The same expression we got, the same result we got here. This is a product rule. Now coefficient rule, also called division rule. In division rule, students, d by dx of u by v. Such problems, first the formula, direct formula, this is equal to the denominator v into derivative of the numerator minus. Now the numerator derivative of denominator by square of the denominator. This is the coefficient rule. We will solve some problem based on these formulas, but we have to remember this. We have to remember this formula carefully. This is a coefficient rule. Here we can see first what we are going to write. The derivative of numerator into denominator minus derivative of denominator into numerator by square of denominator. This is equal to d by dx of u by v. The next one, derivative of sine function. So this can be written as derivative of sine function, d by dx of sine x is equal to cos x. Directly we can write d by dt of sine theta. That means this should be variable. Theta is variable, so this is the theta. So this is equal to cos theta. Similarly, if we take derivative of cosine function, d by dx of cos x will become minus sin x, or dy by dy of cos y is equal to minus sin y. Similarly, d by d theta of cos theta is equal to minus sin theta. Whenever you see these questions, these formulas, if the variable is here is x, cos x, so we have differential with respect to x only. If it is y and this variable must be equal to y. If it is theta and this must be theta. We cannot differentiate d by dy of cos x because d by dy of cos x is wrong. But if you know x in terms of y, then you can do it. Otherwise, always you please check in fundamental questions d by dy of cos y is sin minus sin. Derivative of other trigonometric functions. Already, derivative of sin x is cos x, derivative of cos x is minus sin x. The other functions, d by dt of tan x is equal to secant square x, d by dx of cot x is equal to minus cosecant square x. Similarly, d by dt of secant x is equal to secant x tan x, d by dt dx of cosecant square x is equal to minus cosecant x into cot x. These are the remaining four trigonometric functions and the corresponding derivative. Now, the 10th one, derivative of a logarithmic function. This is d by dx of log x to the base e. This is directly equal to 1 by x. Log x to the base e can also be written as d by dx of natural log x is equal to 1 by x. The next one, students, derivative of exponential function. That is d by dx of e power x is equal to, that remains as e power x only, there is no change. But the chain rule, this is also called inside outside rule. Suppose a function is given as y is equal to f of g of x, then dy by dx can be written as, first differentiate the given function, that is f prime g of x. So first we have to differentiate the given function and then into g dash or g prime of x. This can also be written as, suppose if this function is given as y is equal to 1 by root x square plus 1. This is a given function. Now here dy by dx can be written as, first here let me take this directly root x plus y only. The given function is y is equal to root x square plus 1. Now I want to differentiate this y with respect to x. So this can be written as dy by dx. First, whatever may be the quantity inside this root, first root x is 1 by 2 root x. So derivative of root x square plus 1 is 1 by 2 root x square plus 1, because this is the variable here. X square plus 1 completely variable. So root x variable is 1 by 2 root x. Now differentiate the term inside the root. X square derivative is 2x and derivative of 1 is 0. So this will become dy by dx will become 2x by 2 root x square plus 1. Now you can cancel this 2 and 2 here. Remaining term x by root over x square plus 1.